In this section, we look at how changes in some of the coefficients in the equations for the trigonometric functions affect the amplitude and periods of the graph. The first problem I've written over here is graph one complete cycle of y equals 6 sine x. So we know that this coefficient tells us what the amplitude is. So this graph will have an amplitude of 6, and then the coefficient here in front of x tells us what the period is. So the period will be equal to 2 pi divided by this coefficient, which is 1, so that's 2 pi. So I have a sine curve with an amplitude of 6 and a period of 2 pi. That graph is going to start at the origin. At pi over 2, it's going to be up to 6. At pi, it'll be back down to 0. At 3 pi over 2, it'll be down to negative 6. And at 2 pi, it will be at 0. So I can sketch the graph of that curve real nice and neatly like this, going through those points. So that's a nice quick way to sketch the graph of these trig functions if we just look at the coefficients and then identify from them the amplitude and the period. Here's our next problem. Let's sketch the graph of y equals sine 2x. Now in this case, the coefficient of y equals, the coefficient of sine is 1, so I have an amplitude of 1, and this coefficient here will give me the period. The period is going to be 2 pi. Whoops. Let me get that right. 2 pi divided by this coefficient, 2, which is just pi. So this graph will be a sine curve. It'll go through one complete cycle in pi units on the x-axis, and it has an amplitude of 1. So it's a sine curve. It starts at 0. It's going to end pi units later here at 0. Halfway between, it'll go through 0. And here at pi over 4, it's going to be up to 1. And at 3 pi over 4, it's going to be down to negative 1. So by comparison, that graph is going to look like this. So you can see, if I extend this graph, that it's going to look like this. Just so you can see what this coefficient 2 tells me is that this sine curve is going to go through 2 complete cycles in what was one period of 2 pi. So if I take the old period 2 pi and divide by 2, I get the new period for this function. So 2 pi divided by 2 is pi, and you can see that that graph goes through one complete cycle, pi units on the x-axis. Here's our next one. Y equal 1/2 cosine 3x. I want to sketch the graph of this. Okay, it's a cosine curve. It has an amplitude of 1/2, and it has a period of 2 pi divided by this coefficient 3, which is 2 pi over 3. So it's going to go up to, let's see, I'll call this 1/2 on the y-axis, and this will be negative 1/2. It's going to have a period of 2 pi over 3, so I'll put 2 pi over 3 out here. It'll go through half a period, and half of that, which is pi over 3. Half of that will be pi over 6. So I have 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2. So this is going to be a cosine curve, so it will start up at the amplitude of 1/2, come down to 0, go down to negative 1/2, back up to 0, and then back up to 1. So if I sketch one complete cycle of that cosine curve, it will look something like this. So a nice quick way to sketch these curves is just identifying these coefficients here and how they affect the amplitude and period of the graph. Our next problem is taken from the problem we just did. Let's sketch the graph of negative 1 plus 1/2 cosine 3x. Well, I already have my 1/2 cosine 3x right here, so all I want to do to each of these values of y right here is add a negative 1 to them. So where I did have 1/2 for y, when I add negative 1 to it, I'm going to end up with negative 1/2. Where y was 0 right here, when I add negative 1 to it, I'm going to be down to negative 1. And where y was negative 1/2, when I add negative 1 to it, I'm going to be down to negative 3/2. When y was 0, when I add negative 1, I get negative 1. And when y was 1/2, when I add negative 1, I get negative 1/2. So that curve will look like this, and it should look like my original graph, just with all the values of y brought down 1 unit. And it does look like that. They sort of parallel each other like this. This graph is simply, the black graph is simply 1 unit below the red graph. So a little variation on graphing with amplitude and period.